In this segment, we're going to take a look at box logic. Unfortunately, we cannot do that here in the studio, so we're going to have to take a road trip. Today we're headed for Stanford University's renowned Logic Laboratory. Follow me. And here we are. This is the Logic Laboratory. It may not look like much, at least not superficially, but this is where we investigate some of the latest innovations in logic technology. Today our goal is to look at box logic. Now the language of box logic is pretty simple. There's really just three constants. There's large box, there's medium box, and there's small box. And they're all oriented one way or the other. Forming compound sentences from our constants is easy. If we want to negate a sentence, we just invert it. Not medium box, medium box. If we want to form a disjunction from our constants, we stack them up. So here we have small box or medium box. And a conjunction is formed simply by placing multiple boxes or stacks of boxes on our table. So it's effectively clausal form. Okay, now let's try to use our logic to solve some problems. How about the case of Mary, Pat, and Quincy? You recall that if it's Monday, Mary loves Pat or Quincy, and Quincy, if Mary loves Pat, Mary loves Quincy. Let's see how we can represent that information using our new language. So first of all, if Mary loves Pat, Mary loves Quincy. Let's let this medium-sized box represent the fact that Mary loves Pat. This one represents Mary loves Quincy, and the large one is going to be Monday. So we want to say, if Mary loves Pat, Mary loves Quincy. How do we do that? Recalling the rules for converting to clausal form, we know that P implies Q is equivalent to not P or Q. So if you wanted to write that, we would write not Mary loves Pat or Mary loves Quincy. So not Mary loves Pat or Mary loves Quincy. If Mary loves Pat, Mary loves Quincy. How about our other sentence? If it's Monday, then Mary loves Pat or Quincy. It's Monday. Let's see, we need to say not Monday or Pat or Quincy. So not Monday. More copies. Or Pat or Quincy. So there we have it. If it's Monday, Mary loves Pat or Quincy. If Mary loves Pat, Mary loves Quincy. Representing the premises of the problem. Now you may recall that the object of the problem was to show that if it's Monday, then Mary loves Quincy. So how could we do that? All we've done is represent things, but we can also do computation, deduction, with box logic. The rules are pretty simple. If we ever have one stack which has a constant, a literal, which is the complement of a literal in another stack, we can do resolution on them. So here we have one stack with medium box down, here one stack with medium box up. We can combine the two stacks, eliminate the complementary literals, and form this answer. Since this is a duplicate, we can throw that one away. And we're left with our conclusion. If it's Monday, Mary loves Quincy. Nifty. Okay, well, what's the point? The point is that the language of logic is not about particular sets of symbols. And the act of deduction doesn't mean necessarily that we're operating upon those particular symbols. Logic is an abstraction. Any instantiation of the symbols is equally good, and any operations on them is equally good, provided that it respects that basic abstraction. Okay, that's it for our visit to the Logic Laboratory today. We'll be back again later in the course with some additional demonstrations, and we'll see you then.